Okay, we're going to look at interval notation, and we're going to connect that to domain and range. But first, what is interval notation? And you need to know the symbols for it. And one of the symbols that we need is, or the idea of, is the affinity symbol. And the infinity symbol, which is right here, means you're going right or up forever. Basically, you're getting big, and and it's moving in a direction where you're only going to get bigger and bigger. So you're 10, then you're 100, then you're 1,000, and so forth. That's infinity. It's not a number. You can't equal it, but it is an idea of getting bigger and bigger. Negative infinity means going left or down forever. So negative 10, negative 100, negative 1,000, etc. Again, it's not a number. It's an idea of going down forever. A bracket, square bracket, which could be a left bracket or right bracket, means or equal to, or that the end counts in an interval. It would be like an inequality that's underlined. Okay, so here's a picture of what would be that would require a bracket. If this is filled in, we would use a bracket here. Parenthesis means not equal to, so the exact opposite, or that the end does not count in the interval. So number line would be this number here. Since it's open and the boundary itself cannot be equal or is not part of the interval, we use a parenthesis instead of a bracket. So an example, we have this picture, same picture we had before. X greater than or equal to 2 certainly is what you would say here. 3, 4, 5 are bigger than 2, and you can actually equal to, so it's filled in. In interval notation, we use this, and it's going to explain down here, but the bracket means that the left boundary is filled in. You can equal the left boundary. 2 is the left boundary, okay, or the small boundary, the lowest it will ever go. Okay, because it goes forever this way, the arrow is filled in, then we say infinity. That means, yes, you can only see the 5, but it goes 6, 7, 8, 10, 100, 1,000. It keeps going. And then we finish with a parenthesis. Parenthesis, remember, means you don't actually touch that boundary. You can't touch infinity, because no matter how far you can always go one more. Infinities are always going to get parentheses. So bracket 2 to infinity means my left boundary is 2, my right boundary is forever to the right. I can equal the 2, I can't equal the infinity. And just a reminder that negative infinity and positive infinity always get parentheses. A second example, which you may not be able to see too well, but it's shaded to the left, and there's an open circle here on the 8. Alright, so consider the diagram. X less than 8. Few would argue with that. It is in fact x less than 8. Notice it's not underlined. And then a little different here. Remember, we put the small number first, so wherever the left boundary is. Well, there is no left boundary here. It keeps going. So we say negative infinity, though you don't actually see any negatives here. We're heading in that direction. 6, 4, then 2, then 0, then negative 2, and just keeps getting more and more negative. So that's why we put negative infinity first here. The small must always come first. Okay, this value is always smaller than this value. 8 is the right-hand boundary. As we said, parentheses always go in infinities, and here the parenthesis goes in the number as well, because you can't equal 8. 7.99 is okay, but 8 is not. Okay, then it's going to explain that. Domain and range. Domain would be all possible x values of a graph. Range, all possible y values of a graph. And to do the domain and range of a graph, you have to picture, you don't absolutely have to, but it's a good idea to picture a number line for the x's and a number line for the y's, and then go from there. So here's an example. You have this graph. Okay, we're going to talk about the domain and range of this red part. Well, domain, remember, is your x values. So for x values, a number line might look like this. Okay, maybe a little hard to see here, but this is 6, 7, 8, 9, 10, and continues from there. Well, this is 6, 7, 8, 9, it just keeps going. Okay, 10, 11, it goes off the graph in that direction. So we've already talked about how to do the inequality notation and the interval notation here. Bracket, because it's filled in, it goes right forever. Now range, we're going to do it for the same graph, and for range you don't look along this line. Range remembers the y base. Well, this is the y right here, so it's like you kind of turn this sideways in your mind and you're doing a number line right here. Okay, so your number line, before we look at this, let's look at the number line, would be 0 to infinity. What I've actually done is taken this right here. Okay, it's going to be, and because it's going this way, it goes down to 0. I know it looks like it's going to 6, but if you think down and up, we go down to 0. This point right here is 0 over here, and it goes up forever. Okay, so that's why it's shaped like this. And these values would match along with it. Notice for range we put y instead of x. We've had x for domain, but the interval notation here doesn't care if it's x or y, and that's going to explain that. One more example, and here looks like the animations aren't quite working correctly. So let's just put everything on the screen. Okay, so consider the following graph. We have it kind of backwards here. The domain could be drawn. Now this one's going backwards because it looks like it's going to the left, or there's no arrows on it, but you would assume it just continues going like this, but it stops at -1. So for domain, remember we take these numbers. So that's what I have here, these numbers. And it's filled in, you're fine, -5, -4, -3, -2, then -1, you're still fine. But then there's nothing past that. Okay, so that would be x less than or equal to -1. Or remember, native infinity would be going this way forever to -1. The range, okay, again, remember we take the y values. Okay, so it would be 4 or -4 and then up from there. Okay, and you can see the corresponding interval notation and interval notation here and inequality notation.